Good day, grade 10s. So today we are doing trigonometry. So trigonometry here will be dealing with just the relationship between angles and sides of triangles. In grade 10 we explore how angles are represented on a Cartesian plane and how they relate to trigonometric functions. Number 1, let's talk about association of angles on Cartesian plane. Now, Cartesian plane is a grid with x-axis and y-axis. So this is your Cartesian plane, right? And then angles are measured from positive axis in an anti-clock direction. So when you measure the angle, we measure from this line, we go like this. This is how we measure the angles on a Cartesian plane. Right? The full rotation is 360. You see this full rotation is 360 degrees. So we start from 0, 90, 180, 270, 360. Full rotation, circle. And then 0 to 90, it's first quadrant. 90 to 180, second quadrant. 180 to 270 is the third quadrant. 270 to 360, it is the fourth quadrant. So the trigonometric functions you have to you see, I have to talk about something here on the Cartesian plane. What are these things? These ones are the trigonometric functions, right? We have sine, cos, and tan. But then what's going on here? Well, here I was just showing that they are all positive in this first quadrant. And then in this second quadrant, only sine is positive. On the third quadrant, only tan is positive. On the fourth quadrant, only cos is positive. Right? Meaning that tan and sine in the fourth quadrant, they are negative. And then what else? Sine and cos in the third quadrant, they are negative. And then also tan and cos in here, they are negative. But here, all of them, they are positive. Right? So on the Cartesian plane, this is your y-axis, the one that is vertical. This one is your x-axis, the one that is horizontal. And then from here to here, you have a positive numbers. You have positive numbers from here to here, and then you have negative numbers from here to here. And then you have positive numbers from here going up, and then also negative numbers from here going down. So I can say negative numbers as you go down, and then positive numbers as you go up, positive numbers as you go to the right, and then negative numbers as you go to the left. That's your Cartesian plane. In addition to the trig functions I introduced, these are the other ones you have to know. Cosec is 1 over sine, sec is 1 over cos, cot is 1 over tan. And that means here we have to invert whatever tan is. What is tan? Tan is sine over cos. So you're going to end up with what? Cos over sine. Taking note that is the inverted form of this ratio here. So let's quickly go through a test question. In your March test, you can get something like this. Given 3 cosec theta plus 2 is equals to 0. And then they give you they specify where the theta falls, or like where is this angle gonna lie. So from 90 to 270 on the Cartesian plane, you can realize that that's gonna be the second and third quadrant. That is very important. Take note of that. When they tell you that theta lies between 90 and 270, that means the theta is lying on the second and third quadrant, right? Because you can see that 90 starts here, and then is 270. So we go like this. Second quadrant and third quadrant, we know our solution is either going to be in this quadrant or this quadrant. We don't know yet, but we know that between these two, that's where we're gonna find our solution. So this is actually the question. Use a sketch to determine the following without using a calculator. They want us to determine cos theta, And then the second thing they want us to determine is sine theta by tan theta all over cosine of theta. So the first thing you can do when you're given a question like this, you can first solve cosec. Let's solve for that cosec. Take 2 to the right hand side, it's going to be negative. Divide both sides by square root of 3. Here we go, you have cosec. But what is cosec? Cosec is 1 over sine, meaning that if you invert this number, meaning that your negative 2 is going to be now at the bottom and your 3 is going to be at the top now. Then you'll have your sine. Just invert your cosec, you'll have your sine. If you invert your sine, you have your cosec. You get it? So we now have what? Sine. So, but then they don't want sine, they want cos. Okay, so what I can say is that this sine is going to help us to get what? Cos. Let's now draw a sketch on a Cartesian plane. But before I talk about this sketch, let's quickly go through these 3 things. So, Katua. This one means that sine of theta is opposite over hypotenuse. This one means that cosine of theta is adjacent over hypotenuse. Tangent of theta is what? Opposite over adjacent. So this is how our sketch is looking like. How did you come up with this sketch? Well, first of all, you must know that your angle is going to be between this line, which is the x-axis line, and your hypotenuse, right? So you can already see that if it's in the third quadrant, then you have to draw it like this so that your theta can be here between x-axis line and your hypotenuse. So this line, it is the longest side of our triangle. It's actually positive, always positive. So meaning that that negative is for the square root of 3, which is the length of our triangle on a negative y-axis sections, meaning that start from the center going downward with the negative numbers. Because as you can see that from here going up, we have what? Positive numbers. And then from here going to the right, we have positive numbers. From here to the left, we have what? Negative numbers. So that means this negative 3, it is the measurement of the triangle from this point up to this point. So you can see that is where on the negative axis line of the y-axis. So let's solve for x then. Let's solve for this x using theorem of Pythagoras. With x squared plus y squared is equal to r squared. As I've said, r squared is what? Positive. So we already know what is our y. Alright, y is negative square root of 3 squared. We're gonna square it. So we solve for x. X is 1 here. And then let's apply square root both sides. We're gonna have x is equals to plus minus 1. So we have to choose between positive 1 and minus 1. Which answer is suitable? The suitable answer is to be negative x, because the triangles is on the negative side of the x-axis line. So minus 1 is the best answer. So how can we determine cos? Cos is adjacent over hypotenuse, right? Or x over r. Cos is what? Adjacent over hypotenuse. So what is adjacent? Which side is adjacent to this angle? It's x. And then hypotenuse is this one, right? So that's why we're saying x over r. This longest side we call it r. This side we call it y, right? So you have what? X over r. That means we're gonna have what? Negative 1 over 2 for cos. Hence this is our answer. And then the second thing they wanted us to determine is sine of theta by tan of theta all over cos of theta. Well, what I used to do is that I express tan in simplest form, which is sine over cos. We still have the division line cosine theta. Sine theta by sine theta over cos theta. This division line is this thing, cosine theta. Let's write the multiplication sign instead of division, and then we're gonna what? Swap. Once you write times, then you invert this thing. Alright. So sine times sine, sine squared, cos times cos, cosine squared. And then we already know that sine is negative square root of 3 over 2. We square that, divide by cos we know is negative 1 over 2. Then we square it also, because you can see they are both squared here. This squared here is going to cancel the square root here. We're going to be left with what? 3. And then 2 to the power 2 is going to be what? 4. And then 2 to the power 2 again, 1 is going to be what? 4. This division line here, we can write a multiplication sign and invert. So we're going to have what? 4 over 1. So that means we're only going to be left with what? 3. It's our final answer. So what about these negatives? Where did they go? Well, we know that when you have a negative number that is squared, the negative is going to disappear, because negative times negative is what? Positive.